The preconceived notion of coding is that you involve a computer or you involve some sort of robot and you have to tell the robot what to do. That is part of coding, definitely, but in the curriculum, it states solving and creating representations using coding concepts. So it doesn't necessarily mean they actually have to block code or write out lines of code at any of the grade levels. It is just using the concept of coding, and I'll go through some of those concepts. The two specific expectations are writing code and reading code. Those are really the two big specific ones, but they're all related to that overall. So how can we break it down so it's a little bit easier to understand? I'm going to use an analogy that's related to dancing, because dancing is really coding, but using your bodies. What coding really means in its purest sense is a set of instructions. That's all it is. Coding means you're giving a set of instructions to do something. So dance is exactly that. You have some instructions to move. How do we move in order? And how can we like manipulate that moving together? So there's a question about, but my kids are in grade 7. How do I teach them grade 7 material? Well, don't start at grade 7. Start back at grade 1. Grade 1 through 5 are all of the coding fundamentals. And to be truthful, you can easily teach grades 1, 2, 3 in one lesson, one activity. Then you can add grade 4 stuff in another lesson, grade 5 in another lesson. And if that's done, if that's all you could do is grade 1 to 5 this year, we know that for next year. So maybe that might be the next step you write in the report card, to look at the grade 6 program and the grade 7 program as a next step, so that next year that teacher can pick up from where you left off. And then in a few years, we're hoping in 2 or 3 years that the entire system will be at the appropriate grade level. But it's important to write it in the report card to see what strength have they achieved at that point. So let's start from the beginning. Grade 1 means sequential steps. So if I'm telling one person to dance a shuffle, then a floss, then a march, I'm doing those steps one at a time. That's grade 1. That's all you need to do. For grade 2, you have 2 people dancing independent steps of each other at the same time. So one does a shuffle, floss, march. The other one does a disco, V-step, jazz hands at the same time. We call that concurrent. Let's move to grade 3 control structure, which is called repeating. This is now, instead of writing out so many lines of instructions, you will just repeat it a certain number of times. An analogy would be in cooking. If you're creating multiple sets of muffins, you're not going to rewrite every step for every batch of muffins. You'll just say repeat the recipe with this, with this new set of ingredients. So in this case, I am minimizing that block. So it's just shuffle, floss, march repeated 5 times. Nested moves are where I take a repeat, but I put it within a repeat. So shuffle, floss, march, shuffle, floss, march, shuffle, floss, march 3 times. Then I do a disco, and then I repeat that entire block 5 more times. That's a lot of flossing. Rosanna came up with it. Well, Rosanna and I worked together to create this document, and she wanted to floss. So apparently she wanted to let that flossing happen 15 times all over again. But it's super fun. I love doing flossing, even though I'm not so good at it. The last control structure in grade 5 is the conditional control structure. This is where you say, if this happens, then that happens. So if I hear the entertainer, I'm going to do this nested code that you have here, this nested dance. If they play happy, then you do that. Like when you hear the Macarena and you hear those first 4 notes of it, you're like, oh, gotta get up on the dance floor, because that's what it tells you to do. The code says when you hear Macarena, you go up and you start doing, this. Like, we're coding all the time on the dance floor. Now, if you don't want to use dance, or if you've already used dance as your example, choose any everyday activity your kids would like, any chore, doing the laundry, making a sandwich, doing the dishes, cooking an egg, or even playing a board game. Let's play Crazy Eights. How would I code Crazy Eights? How would I code playing Snakes and Ladders? How would I code tying my shoelaces? And choosing any one of these everyday activities and having them go from grade 1 to grade 5, you've already finished all of the coding concepts that are needed for that first piece, that control structures. Grade 6, 7, and 8 are all about optimization. How do you make your code cleaner and work faster? So the first one in grade 6 is cleaning up the steps so it's more efficient. Notice here I have, if entertainer plays, I have all this long list of steps, but I can use a nested repeat block to kind of crunch it down. Why would you want to do that? Number one, it saves space in a computer. 5 lines of code is much less data space than 15 or 20 or 500 lines of code, especially if you have a repeat block times 100. Secondly, it moves faster. Rather than reading a long list of instructions, it reads one instruction and can repeat that instruction block many times. So you're trying to create efficient code. The third reason is debugging. Debugging means finding the error. When you have a small block of code that's repeated multiple times, I can find the error really quickly in that nested block rather than trying to sift through 100 or 500 lines of code. So that's efficient steps. Where you're at now, grade 7, again, we know that your students might not be able to get to grade 7 level this year, but it's to understand what it is. It's to use what we call a sub-program. So many of us have danced the electric slide or the continental line dance at weddings, which is grapevine right, grapevine left, you step, touch, step, turn, right? We've all done that. We've all done the fun continental dance. If you have not, then you better learn how to do the electric slide. But the coding is this. So let's say I start in a square formation, then I repeat that sub-program of doing the electric slide 4 times. I can use that with this code, but if I want to change it, I can use that electric slide in another code somewhere else. It's called a function. I'm using that function multiple times in different kinds of code. Lastly is the data analysis. So you don't have to do this year with your grade 7s, but just to show what will happen in grade 8 is where the computer, or in this case, the DJ, realizes what's happening with the output. What is happening on the dance floor? So the computer is always going to be running this program. How many people are dancing? If there's less than 10 people, we'll change the song. The DJ will change the song, or the computer will change the program. If there's more than 10 people dancing, then we'll continue to play that song for 60 more seconds so that the DJ knows, hey, people are enjoying this. We call this an algorithm, where the computer is starting to learn what are the more preferred choices, and it's starting to count those things. So it's running in the background. When you code it, you use a variable in order to code that, and you analyze that variable continuously so that it analyzes that data. So you can use this not only for dancing, but you can use it with really any kind of like activity that you're using that involves a routine. Where are some resources? If you're not sure of the words that I use, nested, conditional, variable, algorithm, go to the Ontario Curriculum website. All of the glossary is fantastic there. If you want individual lessons, like one lesson to just throw into your class because you don't have time to do a full unit, OAME has created a bunch of resources by grade. So if you click on the link in the resource document, you'll be able to just pick one lesson from grade 3 or a lesson from grade 5, and you can do that one with your class. If you want to do a full course and you want to track student progress, code.org is a really excellent tool to be able to track student progress. Also, if you want to do a full project and you want to see the physical changes with your coding, use microbit.org to create some projects to see the actual simulator or the physical microbit, if you have one, working in action with your code. And lastly, if you want to do a full term long project where kids create app and they create kind of their whole development plan, you can connect with the Learning Partnership. They have something called the Coding Quest, where they'll be able to code and build their own apps to meet a need. We've also put in the links, the dance document. So if you wanted to take that document and just read it through, or if you have questions, let us know. And even a getting started document, Rosanna and I created that for you so that you have something to start off with so you can implement coding right away in your classes. Sorry, that was so blah, but hopefully that was really good analogy for you to understand kind of the different components of coding. I'm going to pass it off to Earl to talk about financial literacy.